Welcome everyone. Today we are going to explore how to use Microsoft Semantic Kernel to build powerful AI applications in C#. We will be looking at a practical code example that demonstrates several key concepts, from single prompts to multi-turn conversations and even image generation. But first of all, let's understand what semantic kernel really is. And this is just the beginning. In the next videos, we will dive deeper into more advanced topics like planners and external tools. Semantic Kernel is a lightweight open-source .NET library from Microsoft that simplifies integrating diverse AI models into applications. Think of Semantic Kernel as Microsoft's toolkit for creating smart AI assistants. It's what allows your AI to do more than just answer questions. It's like giving it a brain and hands so it can plan, use tools, and remember things. Semantic kernel acts as a middleware or abstraction layer. Its primary purpose is to simplify the complexity of working with different AI models and providers, standardizing interactions so you don't have to rewrite code if you switch models, for example, from OpenAI to Cloud. While it's primarily a .NET library, Semantic Kernel is also available for Java and Python, making it flexible for teams working across different technology stacks. The framework is composed of several modular components, with the kernel at its center. Other key components are plugins, which are crucial building blocks that extend the AI's functionality beyond simple text generation. Plugins enable the kernel to perform specific tasks, such as fetching real-time data, retrieving database records, or calling external APIs. The kernel is designed to work with various AI services in a unified way. You can connect it to different models for tasks like text generation, chat completion, image generation, and even text to audio or image to text. And finally, extensibility. Semantic kernel is lightweight and highly extensible. Its design allows you to easily add new services and plugins, making it adaptable to future changes in AI technology. So this combination of abstraction, seamless integration, and extensibility makes semantic kernel a powerful tool for building AI-enabled applications. Taking a deeper dive into the key parts of the toolkit, this toolkit is designed to be robust and secure, making it perfect for large companies. It comes with security features and the ability to monitor the AI's behavior so it can be used responsibly. These are the specific cables that connect semantic kernel to other systems. The AI isn't locked into one specific brand or system. You can easily mix and match different technologies to build the best solution for your needs. For example, LLM connectors let you choose which AI brain you want to use, like an advanced one from OpenAI or a more localized one from HuggingFace. Data connectors allow the UI to plug into your company's database or file systems to get information it needs. These are the AI's hands. They allow it to perform actions in the real world. For example, a plugin could be a tool for searching for flights on an airline or for sending an email. Semantic kernel teaches the AI how to use these hands when it needs them to solve a task. This is how the AI can work in a team. You can have several AI agents collaborate on a task, like a team of experts. For example, An agent specialized in flights could talk to an agent specialized in hotels to find the best combination for your vacation. This is what makes the AI remember. A regular AI forgets everything after each conversation. Semantic kernel gives it long-term memory so it can recall what you said in previous sessions and use that information to give you more personalized and coherent responses. This is the ability to connect with other services. Semantic kernel can easily connect to many types of AI models like GPT-4 and to different data sources and services, making it very versatile. Comparing both access methods, talking about management with direct access requires significant manual effort and is difficult to scale. On the other hand, semantic kernel uses a dependency injection system for a much cleaner and more scalable approach. With function calling, with direct access requires you to manually orchestrate when and how external functions are called. In contrast, semantic kernel allows the AI to intelligently invoke defined functions on its own. Regarding context handling, direct access struggles with long conversations as the AI trains to forget earlier context. Semantic kernel, however, has a built-in system for long-term memory, enabling coherent multi-turn conversations. Talking about code structure, following a direct access approach often leads to messy code with ad hoc API calls, making it difficult to maintain. By comparison, semantic kernel promotes a modular structure with plugins, which makes the code more organized, reusable, and easy to maintain. Regarding enterprise features, direct access lacks inherent enterprise features like telemetry and monitoring. Nevertheless, semantic kernel comes with these features already integrated, which is essential for corporate environments. Orchestration with direct access is challenging when building complex multi-step workflows. However, semantic kernel provides a dedicated framework for multi-agent orchestration, simplifying complex logic. And finally, developer experience. The developer experience with direct access can be frustrating and requires a lot of trial and error. Fortunately, Semantic Kernel offers a more structured and developer-friendly experience with comprehensive documentation. All right, enough with the theory. Let's jump into the fun part with the code. A key point to understand is how we build the kernel. As you can see here, we use a builder pattern and then add our service, OpenAI chat completion. This is a form of dependency injection. It means the kernel doesn't create its services directly. Instead, they are injected from the outside, which makes our code modular, testable, and easy to maintain. Let's start with a simple interaction. This method creates a kernel and then enters a loop, sending each of your messages to the model directly. This is a very basic way to interact with the AI. Let's run the code in this mode. Okay, let's ask it how many people live in Madrid. Okay, great. Now let's ask what about Málaga? See what happened? The AI gave us a generic answer. This is because it has no memory of our previous question. Each time we send a new prompt, it's a completely new request. The AI has no context from the past, which is a major limitation for building useful applications. All right, now we are going to solve the problem with the chat with history object. Take a look over this method. This is where Semantic Kernel's built-in memory management comes in. Instead of just sending a prompt, we are now using the chat history object. Every message from the user and the assistant is added to this history. When we send a new message, we send the entire history with it. Let's run this code and let's see what happens. Okay, trying the very same question again. Uh, how many people live in Madrid? Perfect. And what about Málaga? Perfect. The AI now understands the context of the conversation and can give a coherent, in-context response. This is fundamental for any truly useful conversational AI. However, sometimes we don't want to wait for the entire response from the model. This is where streaming comes in. As you can see in this method, we are not waiting for a single full response. Instead, we use a wait for each to process the response as it arrives. Let's run the code in this mode and see what happens. Look at that. The AI's response is being printed character by character or word by word. This is the same streaming experience you see in tools like ChatGPT, and it makes the user experience feel much faster and more dynamic. The fourth demo is about controlling the AI. Let's take a look over the code of this method. Here, we will demonstrate how to control the AI's behavior using the prompt execution settings. We are going to generate a startup idea twice, but with two key settings. On one hand, max tokens. This sets a hard limit on the length of the response. We have set it to 500. And on the other side, the temperature, which controls the randomness of the AI's response. A temperature of 0 makes the response very factual and deterministic, whilst a temperature of 1 makes it much more creative and varied. Let's run the code in this mode and let's see what happens. Temperature 0 at the very beginning, now generating the response. Okay, and now it is doing pretty much the same, but with the parameter temperature with one value. Okay, so it's not easy to double check right now the difference, but the first response with temperature equal to 0 is like more direct and focused, while the second with the temperature equal to 1 is more imaginative, but potentially less grounded. You use these settings to fine-tune the AI's behavior for your specific needs. All right, in the final demo, We are going to use another model for the image generation. So semantic kernel's modularity means we can easily switch to a different model for a completely different task, like text-to-image generation. We are now using the iText-to-image service. Notice that we had only to change this piece of code to get a new service. This is thanks to our dependency injection approach. The rest of the kernel remains the same. The prompt is a detailed description of a travel launch. So let's run this piece of code and let's see what happens. Okay, it is starting up. So it can take a while to generate the image. Wait few seconds, and here is the image generated. So looks nice. Okay, so just like that, the AI has generated a unique image based on our prompt. This shows the true power of semantic kernel plugin model. A few simple changes let us leverage different AI models and services seamlessly. So the conclusion is, to recap, we have seen how semantic kernel helps us build conversational agents with long-term memory, improve user experience with streaming, control AI behavior with prompt settings, and easily integrate different AI models for diverse tasks. So this concludes our tour of semantic kernel fundamentals. Thanks for watching and see you on the next video.